Dr. Tom Spilker, thanks for being here with us today.
Glad to be here.
What are some of the challenges of orbital mechanics? Maybe you can just talk to us about what it takes to get to the moon.
Well, it's a very three-dimensional thing. Most people are accustomed to driving around in their cars, and it's a two-dimensional problem, essentially. Flying in space is even harder than flying an airplane. Flying an airplane is a three-dimensional thing, but with flying in space, you have the added problem that gravity isn't the same everywhere. It's not always pointed straight down towards the center of Earth. It varies with where you are. The other thing is just how much energy you need to do this flying in space. To get into low Earth orbit, you're going about 17,500 miles per hour, and that takes a lot of energy. At that speed, the energy that, say, 1 pound of material has is about 20 to 30 times as much energy as is in 1 pound of dynamite. So it's taking a lot of energy to getting you just to the very first steps of space. And then to get from the Earth to the moon, you essentially have to double that energy to get up there. Now, once you get to the moon, you're going fast enough that you would just fly by the moon and either continue out into space or whip around the moon and come back to Earth. So you have to get rid of some energy. All this takes acceleration. Speeding up and slowing down is acceleration, and that takes fuel. And if you're talking about getting into space, it takes a lot of fuel. If you're talking about going to the moon, it takes even more. Now, the physics that governs rocket propulsion and how much fuel you use tell you that if you're speeding up more and more, the amount of fuel you're using is not going up just straight linearly with how much speed. It's exponential. So if you're doubling the amount of speed that you need, then you need a lot more than double the fuel to get that speed. And so these rockets have, what you're looking at is mostly just tanks of fuel. When they lift off from Cape Canaveral or Vandenberg Air Force Base or something like that, Space Force Base, most of what you see there is fuel, and that's because it's so hard to get to the moon.